Hello guys, welcome to Ramta Solutions. Today we are looking at geometric sequences. I would like you to look at this sequence here. So the sequence is 2, 6, 18, 54, and so forth. Now, take a moment, look at it, and predict how this sequence behaves, or rather tell me how this sequence behaves. Go ahead, I'm going to give you 30 seconds. Okay, you have your answer. Now, what I see here, let me change the color. What I see here is that this looks like it is 2 multiplied by 3. This one here looks like it is 6 multiplied by 3, while this one here is 18 multiplied by 3. What does that tell you? So this tells you the next term is the previous term multiplied by 3. Can you see that? So I see, however, that there's a 3. How did I get this 3? I think we must say, when I look at it, 6 divided by 2. I also see 18 divided by 6. I see 54 divided by 18. All of these, when I look at them, they are equal to 3. Right? Well, with that being said, welcome to geometric patterns. So a geometric pattern has what we call, so this is what is happening. This sequence here, every term except the first is the previous term multiplied by a number. We will call that number a common ratio. Okay, we will call that number a common ratio. Okay, so remember, or rather, let me repeat. A geometric sequence is made of this. Um, Successive terms are made up by multiplying the previous term with a number called a common ratio. Okay, they are made up by multiplying the previous term with a number termed the common ratio. Okay, so I can find a general term of this pattern here. I think I can see. I want you to look at it. Maybe let me do this. I'm going to write it in this way. I have 2, I have 6, I have 18, I have 54. Agree with me that 6 looks like it is 2 times 3. We said 18 was 6 times 3. And I remember I said 6 was 2 times 3. Now multiplied by that 3. Right? Now, I then say we have 54, which was 18 times 3, which I can say 18. We said it was 2 times 3 times 3. However, to get 54, I must multiply it by 3. Now, when I look at it, I can say it seems here I have 2, I see it, times 3. When bases are the same, you add exponents. How many 3's are here? 1, 2, 3. And here I have 2. When bases are the same, we add exponents. How many 3's are here? 2. And then here I have 3 to the 1, so I can leave it here. Okay, maybe let me do this. So this could be times 3 to the 1. And here I think I should say I have 2 times 3 to the 0. Can you guys see that? I have 2 times 3 to the 0. Alright? So I can find my general term. When I look at it, it'll be every number here has a 2. So it seems like it is multiplied by a 2. So I will say our Tn equals 2 multiplied by 3, but I'm not sure 3 to the what. What I see here, I saw that for the first term I had 0, which tells me that it must be, and the first term is 1, so maybe I can say it's power n minus 1. Look at it. If I were to put term 1, I will get, let me give you an example here. Not an example, let me prove it. Term 1, I will get 2 times 3 to the 1 minus 1, which is 2 times 3 to the 0. That equals 2 times 1. Of course, it is 2. Okay, you can try for others. Okay, so I think it works. So this is our general term. Now go back. I see here the first term was 2, and it looks like this is how this sequence behaves. So maybe I should say this sequence, its general term is Tn equals A. I'm going to call that common ratio, I'm going to call it R, and then to the power n minus 1. Remember what I had said? I said this is the first term, this is the common ratio. Okay, this is the common ratio, and of course this is your n number. Now I had said to you, it looks like common ratio is 6 divided by 2, 18 divided by 6. It looks like it is term 2 divided by term 1, term 3 divided by term 2, just like that. Right? So I will say then that our common ratio is term 2 over term 1, which we can also say is equal to term 3 over term 2, or term 4 over term 3 in this form, so and so forth. Alright, in this form. So when you look at this, it tells us that, you know what, we are done. We have found the general term of this guy. Okay, we have found the general term of a geometric sequence. Okay, we have found the general term of a geometric sequence. Now maybe let's try an example. We will try an example again. I will say find the general term. Maybe let me write it in the next page. So this example, we will say find the general term. Okay, we will say find the general term, maybe of two examples. Two examples will do. 128, 64, 32, and so forth. Number 2, 0, 0.25, 0, 0.5, 1, and so forth. Right? Now, let's find our answers, or let's answer the question. So, number 1, we said we have 128, 64, 32, and so forth. If you were to find the common differences, you will realize that they are not common. So you're not going to find a common difference, which does not make it an arithmetic sequence or a quadratic sequence. So when I look at it, it looks like this is a geometric sequence. So let's see. R equals T2 over T1. What is T2 over T1? It is T2 is 64. What is T1? It is 128. This tells me that this is 1 over 2. Let me try with T3 over T1. It must be common. This is 32 over 64. What is this? It is half again. So this means we have a common ratio. Okay, we have a common ratio. Now we can find our general term. Tn equals a r to the n minus 1. What is a? A was 128. What is r? R is half to the n minus 1. You can leave it here, it's okay. Otherwise, you can further say this is 128 times 2 to the minus n plus 1. Somebody says to me, 128, can it be 2 to the power something? 2 to the power 7. Come on, guys. You will kill me now. So, this is 2 to the 7 times 2 to the n minus 1. When bases are the same, we add exponents. So, remember, you can leave it here or here, or when bases are the same, you add exponents. Minus n plus 6, or here. It's up to you. Okay, it's up to you where you leave it. Okay, this is fine, this is fine, this is also fine. Okay, so this is how we look at general terms of a geometric sequence. Now let's then look at okay, the second one was 0, 0.25, 0, 0.5, 1, and so forth. Let's see, our R is T2 over T1. It's important to write this formula. What is T2? 0, 0.5. What is T1? 0, 0.25. And then this is 2, right? Now, Tn equals a r to the n minus 1. What is a? It is 0, 0.25. What is r? It is 2. Alright? And then n minus 1. You can leave it here. Or you can say this is 1 over 4 times 2 to the n minus 1. I'm not going to do what I did in the previous example. You can do it whichever way you like. Okay? You can do it whichever way you like. You can leave it here or you can further expand this. It's okay. Okay, guys? This is how you find your general term. Okay? Remember, if you try to find differences and it doesn't come to a point where they are equal, they are common, just try to find a common ratio. That means your sequence is geometric. Okay? Cool. Now, let us try one last example. So this will be example 2. Let me change the color. This will be example 2 that says, the second term of a geometric sequence is 3. So the second term of a geometric sequence is 3, while the seventh is 22 and 55. Oh no, sorry, 22 and 25 over 32. Now the question says, calculate the A, or calculate the first term and the common ratio of this sequence. And then, yeah, of this sequence, I'm going to leave it here, of this sequence. Now, let's look at it. Oh, I should also say maybe this should be 2.1, and then 2.2 should say determine T4. Okay? Now, our solution rather will be, we know this is a geometric sequence, they told us, so it'll be Tn equals AR to the n minus 1. So we're looking for the second term, so this means where there's n, I will put 2. Therefore, T2 equals AR to the 2 minus 1. This, they said, T2, they gave us the term value, they said it is 3. So 3 equals AR to the 1. I'm going to call this equation 1 because I don't know what is my A, I don't know what is my R. Now I'm moving to this 22 and 25 over 32. So I will say this is on my calculator. 22 and 25 over 32 is 729. Yeah. Let me see. 25 over 32, 729. So it is 729 over 32. All right. So we are looking for the seventh term. They said the seventh term is, again, where there's n, I put 7. Right? So I will say, what is the seventh term? 729 over 32 equals AR6. I'm going to call this equation 2. Right? Now, hear me out. I will say equation 2 is AR to the 6. Equation 1 is AR. So, how about I say equation 2 divided by equation 1? Right? What do I mean? 729 by 32 divided by, it was 3. Okay. Divided by 3. And here, it is AR6 divided by AR. Right? Divided by AR. It says to me 729, okay, I still have my answer on display, divided by 3. I have, yeah, I still have it on display. I have 243, look at it, 243 over 32. Okay, I have 243 over 32. Let me go back. Now, this one is out. This one will cancel one of this. I'll be left with 5. So I will then have 243 over 32 equals r to the 5 equals r to the 5, right? Equals r to the 5. Now, I then need to do this. 5th root of 243 over 32. On my calculator, I will simply say 5th root of answer. My calculator returns 3 over 2, right? My calculator returned 3 over 2. With that being said, I am okay. Now, the second question says, I must find T4. I know what is A. I know what is oh, I don't know what is A. So I will substitute this value on either equation 1 or equation 2. I prefer equation 1. It is easier. Alright. So I had 3 equals A into 3 over 2. This looks like A is 2, right? 3 divided by 3 over 2, it looks like A equals 2. Therefore, I can find my 2.2. Right, remember, here I have substituted my R into equation 1. Whether you use equation 1 or you use equation 2, it doesn't matter. They will all give you this value. Now, for 2.2, I'm looking for term 4. Before that, general term is AR. Remember, AR to the n minus 1. What is our A? Our A is 2. What is our R? Our R is 3 over 2 to the power n minus 1. Remember, these are not cancelling. Okay, these are not cancelling. So don't make the mistake of cancelling. This power incorporates the whole fraction. Okay, now I'm going to look for T4. So now T4 equals 2 times 3 over 2 to the power 4 minus 1. Let me get my answer. 2 times our answer is 27 over 4. With that being said, we have done your geometric sequences and it's a wrap. See you next time. Bye bye.